Hi and Assalamualaikum. Today our group is going to present our experiment 5 on CHM260 about gas chromatography. So we got our team members Muhammad Zurazi, Muhammad Hazim Adif, Ikmal Hisham and Adam Haris.
Introduction. Gas chromatography (GC) is a lab method used to separate and analyze the different parts of a mixture that can easily turn into gas. It works using two main parts, a moving inert carrier gas, the mobile phase, and a fixed coating inside a long tube, the stationary phase. Your sample is heated until it turns into a vapor and the carrier gas sweeps into the tube. The different parts separate because they boil at different temperatures and interact differently with the sticky walls inside the tube. Fast moving parts exit the tube first, exit earlier, while slower parts take longer to exit later. As each part exits, a sensor detects them and display them as visual peaks on a final chart called a chromatogram.
For this experiment objective, first one to determine the retention time of N-butanol and 2-propanol. Second, to identify the component present in standard mixture based on the retention time. Third, to identify the component present in an unknown sample. Fourth, to determine the effect of temperature on retention time and resolution.
Next, let's look at the methodology using this gas chromatography diagram. The process starts with the carrier gas, which moves the sample through the system, regulated by the flow and pressure regulator to keep the stream steady. Next, the sample is injected at the injection port, where it instantly turns into vapor due to the high heat. This vapor then travels into the column inside the oven. The column is a long coil tube where the actual separation happens as different compounds move through it at different speeds. As they exit, the detector senses each compound and sends a signal to the computer for data analysis. This generates the peaks you see on the screen, allowing us to identify each component. Any leftover material is safely collected in the waste class. That's a brief overview of the GC methodology.
There are 6 components in gas chromatography. First one is carrier gas tank. This tank holds the moving gas nitrogen that push your sample completely through the machine. Number 2, pressure regulator and flow controller. This part acts like a valve to keep the gas moving at a steady, perfectly controlled speed. Number 3, auto sampler or injector. This component automatically injects your liquid sample and instantly heat it into a gas. Number 4, column and column oven. This is a long heated tube where the different chemicals inside your sample get separated. Number 5, flame ionization detector. This sensor uses a tiny flame to detect each chemical compound as it finishes the race. Number 6, data system. This computer converts the sensor signal into a final graph with a visual peak for you to read.
So for this part, we get 3 different graphs, which is N-butanol, 2-propanol and unknown sample. Based on the graph, we get to see the 2-propanol standard show its retention time at 2.709 minutes, while N-butanol show its major peak at 5.949 minutes. Why there is a difference in retention time for both samples? This is because 2-propanol possess a lower boiling point and higher vapor pressure, or we call it as higher volatility, than the N-butanol. For the unknown sample, we get its retention time at 5.950. It is quite similar to N-butanol. So I can conclude that the unknown sample is the N-butanol based on the retention time and the peak at the graph. And for this another part, we get to see three different graphs but the same sample, which is the standard mixture, but at the different temperature. For the standard mixture at 70 degrees Celsius, we get to see that the major peak from one major peak to major peak is quite far, rather than 100 degrees Celsius and 140 degrees Celsius. This is because when we increase the heat, the mixture is prone to become more volatile because they are reaching their boiling point. So it makes the retention time more lesser and also making the resolution is decreasing. And this is the data that we get from the graph.
So let's look at several questions. First one is, state the types of compounds which are suitable for analysis using gas chromatography. The types of compounds suitable for gas chromatography analysis are compounds that are volatile, thermally stable, and able to vaporize without decomposing. Example includes alcohol, hydrocarbons, and ester. In this experiment, 2-propanol and N-butanol are suitable vaporized and separated in the GC column. The second question is, why is FID for this analysis? The answer is, the flame ionization detector or FID is suitable for this analysis because it is highly sensitive to organic compounds containing propanol and N-butanol are organic compounds. It also provides good sensitivity, a wide linear range, and produces a low response to carrier, gas, and water. The last question is, list two factors which can increase the efficiency of a GC column. The answer is, two factors that can increase the efficiency of a GC column are using an optimum carrier gas flow rate and selecting a suitable column dimension. A flow rate that is too high or too low. In addition, using a longer column or a column with smaller can improve separation and produce sharper peaks. Look at discussion. The standard mixture contained N-butanol and 2-propanol, which were differentiated based on factors affecting retention time, particularly boiling point. 2-propanol with a lower boiling point eluted faster, while N-butanol with higher boiling point eluted more slowly due to stronger interaction with the stationary phase. The unknown compound retention time matching that N-butanol confirmed that the unknown compound was N-butanol. Furthermore, we also analyzed the effect of column temperature to retention time, which the higher the column temperature, the shorter the retention time. This is because it may influence the viscosity of the mobile and stationary phase. Thus, it fastens the compound to elute. Moreover, as a peak resolution, it also may increase the peaks becoming more sharper. Finally, we came to the conclusion. Gas chromatography was successfully used to determine the retention times of 2-propanol and N-butanol and to identify components in both the standard mixture and unknown sample. Increasing column temperature was found to reduce retention time and affect resolution. Overall, the objective of compound identification and studying the effect of temperature on chromatographic separation were achieved.